So let's look at something a little bit more fun. Let's look at streamlining. Streamlining is the process of reducing the coefficient of drag. Specifically in this section, we're going to look at cars because reducing the coefficient of drag has a lot of effect on cars, and because if you reduce the drag on a car, you reduce the amount of energy the engine has to put in, which, more importantly, reduces the gas mileage. Now, we'll point out your book has a wonderful section on the coefficient of drag on cars. I'd encourage you to go read it. Once again, it's kind of cool. So, what does coefficient of drag streamlining do? Well, we look at, this is a car from, I think this is from the 50s. And so what you're seeing here is these are what are called smoke lines. And so what a smoke line is, you put a car in a wind tunnel, you put a column, a metal column down with a bunch of taps in it. Each of the taps will release a string of smoke, perfectly collimated. When the wind comes through, it doesn't, it's a laminar flow, so it doesn't mix the smoke up, and then you blow it over a vehicle. And what it allows you to do is it allows you to see where it's going to disturb the flow. Like this guy right here, you can see there's big voids in here, and actually let's change that color to be, just use the highlighter. You can see there's a void in here, there's some weird stuff going on here, the stuff is getting mashed up in here. And so these are all places where you're going to have issues with the vehicle trying to push its way through. Because remember, difference between a streamlined and a blunt body, whether it disturbs the flow a lot or whether it doesn't. You can just physically look at this and go, yeah, that's disturbing the flow quite a bit. Well, this whole process of streamlining is, within like 40, 50 years, we've gone cars that look like this to more of cars that look like this. And now you can look at it on the top part here, there is almost no disturbance of the flow. It just cuts right through it. The bottom one here, you can see that it's going under. It's going under fairly well. There is some, that highlighter isn't going to show up in that color. There is some disturbance. I'm just not going to win. There's some disturbance of the flow here, but that's not as bad as things have been in the past. And so streamlining actually has a big effect on what's going on with vehicles and the way they're designed. Now, obviously, some vehicles, they just don't care. Now, this is the only smoke line that I can find of a Jeep, which is what I drive, and we don't care about things like coefficient of drag. But it's kind of interesting because as you can sit there and you can look at like the history of cars. And so these are the design changes of a Lamborghini. This is 1967. We can go to 77. Right up here with the gull wing doors and the purple, that's 1990. And then this is a concept car. But as you can see, as we move along, you can see it's getting more and more streamlined, less and less angular. And actually, if you really want to look at a car and just amazing aerodynamics, fluid dynamics of a car, look at an F1 race car. Those cars are one of the most phenomenally engineered things in the world. You've got strength of materials because that thing can hit a wall at 250 miles an hour and the guy will walk away because of the titanium coffin that's built around whoever's driving the car. But the aerodynamics that go into that car are amazing. Which wheels are open, which ones are closed, what the spoilers do, and we'll talk about that a little bit towards the end of the class when we talk about airfoils. We'll talk about exactly what those are doing. Now, I did take a look, and I'm like, what is the most aerodynamic car produced? And as a couple years ago, it was the Volkswagen XL1, has a coefficient of drag of 0.19. That's really low. I believe a Prius is in the order of 0.29, if I remember right. I think my Jeep is something like 0.5, 0.6, 0.7, somewhere in there. And so this whole process of streamlining is all just about reducing that coefficient of drag.